So we had, just to put it back up on the board, 8x cubed minus 1 over 2x squared plus 3x minus 2. And then we factored the numerator, and it factored into 2x minus 1 times 4x squared plus 2x plus 1. And then the denominator factored into 2x minus 1 times x plus 2. All right. So now you see we got common factor 2x minus 1 in the numerator and denominator. And those two factors cancel as long as the factor doesn't equal 0. Because if the factor equals 0, right, in denominator we got 0 times this, and 0 times x plus 2 is 0. Okay? And you can't divide by 0 in math. And so when you solve for x, you get x can't equal 1/2. So these two factors cancel as long as x doesn't equal 1/2. Okay? And so that simplifies to 4x squared plus 2x plus 1 over x plus 2 under the condition that x does not equal 1/2. Okay? So now we can evaluate the limit down below. The limit as x approaches 1/2 of 8x cubed minus 1 over 2x squared plus 3x minus 2. And again, right? So what does the limit tell us if it exists? Right? The closer x is to 1/2, the closer the value of this rational expression is to some number. Okay? So the first step from the top of page 2 is direct substitution. So when we put in 1/2 in for x in the numerator, we have 8 times 1/2 cubed minus 1. And then in the denominator, we have 2 times 1/2 squared plus 3 times 1/2 minus 2. Follow order of operations in the numerator, you get 0. Follow the order of operations in the denominator, you get 0. And 0 divided by 0, we know, is undefined. So this rational expression is undefined at x equals 1/2, but the limits, they still exist. Okay? So in the limit, x never equals 1/2. It just gets close to 1/2. Okay? So this rational expression, from what we know up here, simplifies to what's in the rectangle. So we have the limit as x approaches 1/2 of what's in the rectangle. 4x squared plus 2x plus 1 over x plus 2. Now again, x never equals 1/2. So this rational expression simplifies to what's in the rectangle. And now you can do the direct substitution. Put 1/2 in for x, And we have 4 times 1/2 squared plus 2 times 1/2 plus 1 over 1/2 plus 2. Now you do order of operations in the numerator, okay? And this first term equals 1, second term equals 1, third term's equal to 1. 1 plus 1 plus 1 is 3. And then denominator 1/2 plus 2 is 2.5, which as an improper fraction is 5/2. And we reviewed division with fractions at the beginning of the semester, right? From the review of basic math and algebra. This can be written as 3 times 1 times 2/5, right? Remember, you do keep, switch, flip. And when you multiply straight across, you end up with 6/5. So in math, we write our answers with improper fractions. We don't use decimals. This is some kind of word problem or something like that nature. Okay? So the closer x is to 1/2, the closer the value of this rational expression is to 6/5. Okay? Are you with me? All right, so let's flip over to the top of page 4. This next one is not so bad. We have a quadratic in the numerator, quadratic in the denominator. So we have x squared minus 9 over 2x squared plus 7x plus 3. Well, this in the numerator is the difference of squares, right? 9 is equal to 3 squared. So you can write the numerator as x squared minus 3 squared. So bottom of page 2, okay, from the difference of squares formula, that factors into x minus 3 times x plus 3. Bottom of page 2. Now you can also recognize this is actually a trinomial in a sense, okay, where the number in front of the x is 0, right? You can write that as x squared plus 0 times x minus 9, right? 0 times x is 0, so this just simplifies, right, to x squared minus 9. So we reviewed factoring at the beginning of the semester. So you can ask yourself, what two numbers add to 0 and multiply to minus 9? Those two numbers are minus 3 and 3, right? Minus 3 plus 3 is 0. Minus 3 times 3 is minus 9. Okay. Now, in factoring the denominator, we reviewed factoring trinomials where the number in front of the x squared isn't 1, right? And we learned 3 different methods, right, for finding those factors. Now, but if you learned another method in high school, right, and you like it, by all means use it. Okay. So, the denominator, does anybody know what the factors are for the denominator? Anybody? Yep. Yes. Ruby?
6 and 1.
6 and 1. That's not what I got.
I factor by grouping.
Yeah. Anybody else? Corner?
2x
So that factors into 2x plus 1 times x plus 3, right? Remember, we learned the slide, divide, slide method. There's also the box method and X method, right? And then any method, any other method you may have learned in high school. Okay? Just get the right factors. Okay. Well, you can see x plus 3 is a common factor in the numerator and denominator. And those two factors cancel as long as x plus 3 doesn't equal 0. Because if x plus 3 equals 0, we got 0 times this, which is 0, and you can't divide by 0. And so, if x plus 3 can't equal 0, that means x can equal minus 3. So this reduces to this as long as x doesn't equal minus 3. So we have x minus 3 over 2x plus 1 as long as x doesn't equal minus 3. So this reduces to this in the box as long as x doesn't equal minus 3. Okay. All right. Any questions? All right, so now we can evaluate the limit. Okay. So we have the limit as x approaches minus 3 of x squared minus 9 over 2x squared plus 7x plus 3. And you know the first step in evaluating a limit is the direct substitution. So you have minus 3 squared minus 9 over 2 times minus 3 squared plus 7 times minus 3 plus 3. So when you do order of operations in the numerator, you get 0. When you do order of operations in the denominator, you get 0. So we have 0 over 0 form, which is undefined. So even though this rational expression is undefined at x equals minus 3, the limit still exists. Okay. And so in the limit, x never equals minus 3, it just gets close to it. So this rational expression simplifies to what's in the box. And now when we do the direct substitution, we have minus 3 in the numerator, and 2 times minus 3 plus 1 in the denominator. Minus 3 is negative 6. And the denominator is equal to negative 5. And negative over negative is positive. So the closer the value of x is to minus 3, the closer the value of this rational expression is to 6/5. Okay. So this guy is undefined at x equals minus 3. Now, what is this information actually telling us? Okay. Back on page 1, when we were learning what a limit is, right? We had a hole in the graph, right? At x equals 2. And we found the limit as x approaches 2. Right? The value, Closer x is to 2, the closer the value of the function is to 3. So when we have this 0 over 0 form, where the limit still exists, that's due to a hole in the graph. Like on page 1. And now we know the coordinates for that hole. The x coordinate is -3, and the y coordinate's the value of the limit. It's 6/5. So in the graph of this function, right, this is what our f of x is equal to. In the graph of this function, there's a hole in the graph at the point -3, 6/5. -3 is the x coordinate, 6/5 is the y coordinate. And again, we write our answers as improper fractions, okay? Not as decimals or mixed numbers. And on the exam, it'll specifically say that. No decimal answers, no mixed numbers. Okay? I remember working with mixed numbers in high school. Haven't worked with them much since then. Okay. All right, any questions on that, ladies and gentlemen? So let's take a look at the problem at the bottom of page 4. Use binomial expansion to simplify the given expression, then find the indicated limit. So we're going to simplify 4 minus 2 plus h squared over h. So instead of x being our variable, h is. Okay. And in Math 120, right, you learned the definition of derivative, and the definition of derivative involves a limit, and in that limit they use the variable h. Okay. So it's sort of a looking forward to Math 120, Calculus 1. Okay. All right, so we got to simplify this. Now, what sometimes confuses students is this minus sign up front here. This is 4 minus 2 plus h squared. This minus sign is actually the invisible -1, right? You can write that as 4 minus 1 times 2 plus h squared. Okay. And so you know exponentiation comes before multiplication. So what we're going to do is we're going to expand 2 plus h squared, okay? And then we'll distribute the -1 inside the parentheses, okay? To simplify that numerator. So 2 plus h squared, that is binomial expansion with n equals 2. And so from the bottom of page 2, 2 plus h squared, right, is the same as 2 plus h times 2 plus h. And you can get the result also by FOILing this, right? And when you FOIL that, you get 4 plus 4h plus h squared. Right, so 2 plus h squared FOILs to 4 plus 4h plus h squared, which you can also get from using the binomial expansion from the bottom of page 2 to n equals 2. So we can write the numerator as 4 minus 1 times what 2 plus h squared is equal to. Well, putting it in parentheses, it's equal to 4 plus 4h plus h squared divided by h. So 2 plus h squared expands to 4 plus 4h plus h squared. Now we can distribute the minus 1 inside the parentheses. When we distribute the minus 1, right? So we distribute the minus 1 just like you would if this is plus 5 up front. And so we distribute the minus 1, you have minus 1 times 4, which is minus 4. Minus 1 times 4h is minus 4h. And minus 1 times h squared is minus h squared. And now we simplify the numerator. 4 minus 4, you know, is 0. And so we're just left with minus 4h minus h squared over h. Now we can simplify this. There's two different ways to simplify this. Okay. We can factor out a h in the numerator and then cancel the h in the numerator and denominator. Or we can divide each of these terms in the numerator by h. What appeals to you? How would you go about it? Divide each term by h. Okay. So remember, fraction bars are like division symbols, and division does not undo addition or subtraction. So we got to divide each of these terms by h. And so we have minus 4h divided by h minus h squared divided by h. And now you can see the h's cancel in the first term, provided h doesn't equal 0. And you can see right off the bat over here, right, h can't equal 0. Okay. So we have minus 4, and then minus, and then h squared over h, right? Rules of exponents, that simplifies to h. So our original rational expression simplifies to minus 4 minus h as long as h doesn't equal 0. Now I'll show you the other way you could have done this, okay? The minus 4h minus h squared. You notice in the numerator, you have two terms, and each term has h in it, right? So the lowest power of h in these two terms is h to the first power. So we can factor out an h in the numerator. When we factor out h in the numerator, we have h times minus 4 minus h over h. Now, you know that's correct factors because when you distribute the h inside parentheses, you have minus 4 times h, which is minus 4h, and minus h times h is minus h squared. And now you can see the h's cancel, provided h doesn't equal 0, we have minus 4 minus h, same as up here. So when you get to this stage, right, you can either divide each term by h, or you can factor out an h in the numerator and then cancel. Okay. All right. So this rational expression simplifies to minus 4 minus h as long as h doesn't equal 0. Okay. And now we can evaluate the limit. We have the limit as h approaches 0 of our original rational expression, 4 minus 2 plus h squared over h. And so you know the first step is direct substitution. When you put 0 in for h, you have 4 minus 2 plus 0 squared over 0. And when you do the order of operations in the numerator, you end up with 4 minus 4, which is 0. You already got 0 in the denominator. And you know 0 divided by 0 is undefined. So, our rational expression is undefined at h equals 0, but the limit can still exist. Okay. Well, h never equals 0 in the limit, so this rational expression simplifies to minus 4 minus h under that condition. And now when I do the direct substitution, put 0 in for h. This is equal to minus 4 minus 0. Which is equal to minus 4. So this says the closer the value of h is to 0, the closer the value of our original rational expression is to minus 4. Okay. So remember, h gets close to 0, doesn't equal 0. Any questions on that, ladies and gentlemen? Yes? Ruby?
Would we be able to evaluate this in the same way if the numerator does not equal 0?
The numerator?
Yeah, like if
just like 5 over 0?
Yeah.
No. And you will deal with that case in calculus if you take Math 120. Okay. All right. So we go to 1:30, right? So let's go ahead and we'll stop here and take our quizzes, okay?